Hey folks, devs, I'm sorry to say that you are probably developing in an environment that is nothing like production. This is simply because when you're doing it locally, you've probably got a couple of different programs running. You've got them running on different ports. You got your front end compiled to look at the back end and all this other stuff. And that's all well and good for local development. It's nice and fast and you control everything. The problem is that, well, when we bring this to production, we don't have that. First, we have to get rid of all the weird port numbers. We can have them in the back end, but for the front end, anything that touches the client has to be on a well-known port, or we're just going to get blocked by all sorts of stuff along the way. Closest thing you're going to see to that in production is you're going to have your front-end static web server doing your website. You're going to have an API server, maybe a back-end server, some database servers on the back end, and then anything can talk over the various ports and whatnot. But unfortunately, more than likely, it's not going to be that simple. When things get complicated like this, we're looking at a bunch of layers between the user's web browser and by the time it gets to you. And you, in this case, might be a fleet of containers fronted by a bunch of cache servers that don't know about each other all that much. And never mind what happens if this goes multi-tenant, and then we have to deploy copies of these systems per tenant. If you want to get it into my hands and have it deploy seamlessly, scalably, and reliably, here's a few things you can do to make sure that this isn't going to be a big problem. Number one is take a look at the 12-factor application websites. Now, I've got a link below, and these are principles that you can put into your application design that will allow it to have maximum flexibility, scalability, reliability when being deployed into the wild. This takes into account all the stuff that the cloud does really well for you and eschews some of the old world knowledge that we got from data center systems. 12-factor applications are not the be-all, end-all, and honestly, you don't have to have every one of those things put into every application for it to be useful, but it's a good framework. The real important ones for deploying are number 3, store config in the environment. Number 6, processes, execute the app as one or more stateless processes. Number 10, dev prod parity, make sure the dev environments you're doing mass testing in match your prod environments. And number 11, make sure all your logs go to standard out. By putting in as many of those 12 factors as you can into an application, when you hand it off to me, I can now run in virtual machines. I can run it in containers. I could put it on bare metal. I can probably throw it into cloud functions. Hell, I could probably run it off a USB stick and Raspberry Pi somewhere. Doesn't matter. Everything's just going to work. Modern Web 2.0 API-backed websites, you're going to need to talk to your API server. For dev, it's pretty common to just hard code this in, but we can't do that for prod because we don't know where it's going to be. My typical solution to this is to do the following. First thing, if you have settings, keep your dev settings as whatever they are. We're probably going to be doing something a little bit different. First, you want to have a local storage location on your web browser that you check. If it's not there, proceed. If it is there, you take those and use those as your path names. Now you can hard code for local testing with the public website, or you can have it use a test backend on the public website, or vice versa. If that's not there, you're going to take the current window location, do some magic to it to figure out where it's actually going to, and use that. Some people use DNS address to distinguish between the API endpoint or API paths. It doesn't matter. We can probably set up our proxies to do anything you want. All right, our third tip is pretty straightforward. You want to have very sensible defaults for dev, and you want to have a bunch of switches for things in prod that may go wrong. We will set all the parameters explicitly for prod, and this means that they need to be environment variables, or they should be environment variables. How do we download this config file onto our immutable container? Well, that is a different definition of immutable than I'm used to, but all right, let's do it. If you need debugging in the application for whatever reason, have it default to being on, and then we have an environment variable it checks to shut it off. If you have a setting that turns the background green to signify that the site shouldn't be used, make sure it's turned on. We turn it off in prod. If you have something that reports what container something is running on, which is super important sometimes, try that on in dev, have a switch to turn it off in prod. Container VM instance, whatever, just identifier. Number 4, have as many automatic tests available as possible. We want to be able to know if the site is up and running before we flip to it. In modern deployments, we don't just say, hey, let's shut the old site off and turn the new site on. No, that does not work super well. What we're going to do instead is we are going to turn both sites on at the same time, validate that the new site is working, and then flip it into production and shut off the old site. If something bad happens, we can then immediately flip back. More advanced deployments, we can send some traffic to the new site, some to the old traffic. We watch error rates. If they're okay, then we flip everything over the course of a couple hours or something. It's called a canary deploy, by the way. The other ones blue-green deploy. If you get asked for a job interview, now you know. Last thing, tool your stuff for observability. Log. Just have a debug setting that we can turn on production if we want to get more logs. Log anything informational, log any good warnings, log your errors. Make sure your errors are caught. Make sure they're handled properly. In addition to logging, have some tracing put in your application. Something like Amazon's X-Ray, Dynatrace, even just keeping counters and reporting them through a database pretty regularly or a logging system is a great help. What these allow us to do is find out what is happening inside the app when we can't figure it out from the debug logs. Being able to trace a request from start to finish is a huge help when we figure out what it's gone through. Being able to figure out timings on things help us to find slowdowns and help us to find what combination of situations are causing these types of slowdowns in the system. All these things need to go into something cohesive. So use their console effectively, and your logs do too. If you have multiple computers logging at the same time, you need to be able to get to them quickly, and nothing sucks worse than getting to 40 different Kubernetes logs. So you want to use a log aggregation system. CloudWatch on AWS will do it. It's okay. I would recommend some sort of Elasticsearch clone or Grafana's Loki, which is also really good for this sort of stuff. So that's about it. I'm sure there are many more tips that can be given, and if you have them, please let me know. And if I, a humble ops person, can be doing better, please let me know what you need from me to make your life better. I'm your humble servant, Dan. Goodbye, nerds.